Actually, as it is hybrid model, I can't say total parameter memorized, but I think it will be at least 10 millions to 20 millions. But whenever random forest has a less number of models and parameters, and it is nearly some a few lakhs. So there is a huge difference between two models.
Okay. Okay, thank you. That's all from me. Praveen sir, if you have
Okay.
any questions.
Yes, sir. Yes, sir. So, thank you, Nipon. So, can you just go to the slide, the starting slide? Means I just want to see the title of your paper. And your paper ID is 298, right?
Yes, sir.
Uh, Sir, what I am seeing from the sheet which has been shared with us, it is something different. So I think.
Yeah, actually, I do have also the same thing. It is explainable AI driven deep neural network approach for
Yes,
synthetic
sir.
image identification.
Yes.
Robin sir,
So-
ଟିକେ ଦେଖୁଛି ଟିକେ
No. One second. I think the work is same. Only they have changed the title.
They have changed.
but paper ID ବି ଏଠି ଅଲଗା ଅଛି sir.
No, paper ID is 298 only.
298.
Oh, the 298 ହଁ
But the
title
title.
ଟା check କର.
Huh. Okay. So I'm also having a simple question in that table 6 only. Can you just go to the table 6 where sir has identified few issues? Table 6. Yes. So here actually when you are comparing your results, the data type should be same. You cannot compare your result when your proposed method data type is IoT sensor based data. So then you should not have shown this image data or text data. A simple observation from my side. And another maybe one kind of suggestion will be you need to show the this computational complexity part. Means you have told that the computational complexity of this inception ResNet v2 will be more than this, but that kind of comparison should also be there. Then you could have given more um, emphasis on that. Then you categorically can say, okay sir, my proposed method is having very less computational complexity. So that is from my side.
algorithms couldn't pinpoint the RP locations because they work in frequency domain. So in the time domain, they cannot actually perfectly pinpoint the location. But since we are using the dual domain approach, in the time domain also we can pinpoint exactly the location of the RP, which is at the highest, which is at the sharpest point. Like when we saw.
Thank you. Thank you. Sir, I'm done from my side.
Thank you, Thomas. I have one question. At one point, you have
Yes.
said that SPKI, KI, and MPKI, that's the adaptive threshold values, right?
Yes, yes.
But that the video you have shown, you have fixed that value. It is not adaptive you have taken.
So for initial detection, we have fixed the value so that we
What
at
is the
least
value you
start
have
at some
taken?
point. And
What value you have taken?
so it was something around 1.456.
Okay, then after how you have make it adaptive?
So adaptive when suppose sir taking a certain range of the signal and within that range not finding the RP. So for some end here we have taken suppose we set the average as 0.8, which is the general case for a human heartbeat. So within zero and we have taken a factor of 1.6. And within that seconds, which is something around 1.8 seconds, within that range, if we don't find an RP, then we decrease the threshold value, and then we again check for the RP. This is actually the surgeback mechanisms which allows us to decrease the threshold every time we check for an RP. Because sometimes the RP might be a
In every
little
step,
less
how much
intense.
you have decreased
Yes,
the value? Peak value. In every step, how much you suppose you did not find any RP, right? So you are decreasing the value of SPKI and that threshold value. How much you have decreased in each iteration or something like that?
Yes, sir. We are usually decreasing it by using a formula 0.125 into the current peak, like the peak which we have calculated, plus 0.875 the peak SPKI. And the same formula is being used for MPKIS.
Okay, that's all.
Now I define FRID 224 to present that. Yes, so listen, for 90 days, it's not limited.
ये visible now, sir?
Yes, yes, sir.
Yes. All the way setting of 9 to.
My table of contents.
Actually, presentation is not visible, sir. Again, disappear. So if it is, if sir, you can continue. If it is visible to you, you please continue, sir, without any further delay. Okay, okay, sir.
Perhaps it is visible now. Correct?
Um, uh, it has come, but no slide is there. Yes, 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 yes.
So I'm president for the paper title prize in preserving penetrated learning using credits domain transformation for very human classification. This is my table of contents. So, starting from the terminology federated learning is basically a decentralized machine learning paradigm now, where different clients train their model locally and share their weights to the global server, where the weights get aggregated using different aggregation schemes. So, the basic requirement of federated learning leads to it enhances the privacy and security, while without sharing, as we do not share the raw data and we can do the training and get the result. So basically, here the federated learning program shows client-based local training on local data. Then the local updates of all clients were sent to the global server. After that, the global server aggregate and send the updated weights to the local server. And now the local client is and the local server predicts the output based on the aggregated update of the global server. Mr. Surveys, we had observed various researches and we had taken the fast aggregation scalable secure aggregation for privacy preserving federated learning as a base paper where we had observed a proposed PET-SEC aggregation protocol with FFT based multi-sharing scheme. While the other four are the other literature. So we had basically focused first, predator learning can keep up while training the data locally and monitor but still need sensitive knowledge. So it is important that you create a practical privacy which and other things. Aggregation and server-side aggregation along with inverse FFT and global modeling. Here in the methodology, we had achieved two-side implementation. One is the client side and one is the server side. So we can see the program where we can see first in the client side, as we had taken the brain tumor MRI data set, which we had divided as a non-IIT data, medical data, which is similar to the situation in the hospitals. So all the clients locally train their data, and they locally trained data again. The float vector is now quantized using a quantizer. After which we had done the random masking in zero padding, the first level of secure, like secret sharing. So we had now generated the share. After that, those shares, share 1, share 2, share 3, and share 4 are converted to frequency domain, and we have now encrypted those data before sending it to the server, where the server has received the encrypted packets of the share of the model updates. Here in the server side, once we had received the encrypted packets of the like the encrypted, now the server usually exchange the shared keys to the local client to in order to reconstruct and partially sum. Then the partial sum of the decrypted packets again sent to the server side for aggregation and reconstruction. Then we have the inverse Fourier transform and dequantizer, after which we get the global model updates, and those model updates are now again sent to the client for like they are the newly aggregated weights on which the looking client can now train its model. So this is the client-based non-ID data distribution which we had done. So there are a total of 7,153 images, and those are divided into four phases. One is one is the non-tumor, one is the glioma, meningioma, and pituitary. This is the simulation setup which we had done. We can see we had used many components, and we had used different parameters. So basically, we had done 10 rounds for 10 input and 10 input, and we had used normalization as the data application. In resultant discussion, we had found that we had found in training and validation the performance matrices has lies between 90 to 97%, and the precision recall has is above 90. And for the testing, we had observed that the test accuracy along with the precision recall and F1 score is greater than 94, which is quite good for the medical images. So in conclusion, we had implemented the fast secure aggregation protocol on medical image data, where we had obtained a decent accuracy of 94% testing accuracy, and we had implemented the system to practically get an efficient and secure patented solution for medical image analysis. This is the reference section. Thank you.
Okay, thank you for the presentation. I'm having a very simple one, only one question, but at a very simple and trickier. You having three phases, right? One is training, another one is validation, and third one is testing.
Yes.
Can you just give me the difference between testing and validation?
Sir, in validation, we had taken the images. There are two folders actually. So in validation, we had taken the images from the training folder only, like 20% from the training folder, and the testing folder is actually a truly new image, the completely new image which is given to the system in on base of the train data, or in on the base of the train knowledge, it knows that we can know that actually the model is correctly knowing what is the data or not.
Okay, and what is your data set? Where did you get your data set? Okay. And I hope you are a BTech student. Yeah. So all the best. The work is pretty conclusive and crisp. Thank you. Thank you for your presentation.
Yeah, I have one question. So look at this diagram. The diagram you have written aggregated objects sent to the local server. Local is there any server? Or it's local client?
So yes, sir.
So then local one will be called as client and the global one will be called as server. But you have written it is local server. have you gone through the encryption technique which has been mentioned in that let's say aggregation? I mean, how they have encrypted it?
Like what we had right for encryption of S, that is A is encryption, but they haven't mentioned in the paper for which we had gone through. They haven't mentioned a particular encryption data. They have only presented say using keys.
What is the length of key it has generated? 128. Okay, thank you.
Now I invite Parala Maharaja Engineering to present their work.
Let me say. What is the Sir, is it visible? The slide is visible?
Yes, sir. Yes, sir.
Surely, client-level privacy guarantee. Prepaid restricted model is used as it performs well on small datasets. Evaluated the model's performance on individual client datasets to check how each client has individually trained the global dataset and then combine the whole dataset as a total global test dataset. Achieve a reasonable accuracy while maintaining privacy throughout the training process. Methodology. This is the methodology where the overall workflow can be divided into two parts, which is the client side and the server side. The clients, starting from the initial global model, which is the reciprocating model, is shared to the client side at first. Then each client trains the received global model, which is the reciprocating model, accordingly as from their raw data. And after the local training model for each work, they produce local model traits. Then these local model traits are added with differential privacy, which provides noisy updates. These noisy updates then can be encrypted using server public key, and then these encrypted updates from all the clients, similarly after doing the same process, are taken to the server side, where they are aggregated and updated the local. This is the client side in a detailed form where firstly the receipt model is the REST ADT model, and I have taken 5 clients, so I have drawn 5 clients, and the local training of for E box where E I have taken is 5, and then W is generated, W means made, and then after applying the differential privacy, WB is generated, which is the differential wait after differential privacy. Then the encrypted data using homomorphic encryption with server public keys perform, which produces WE, which is the encrypted bit. Then in the client side, in the server side, each client has produced the WE, which is the encrypted bit. We go to aggregation, where the encrypted bits are aggregated, and then the aggregated bit is then decrypted with the help of a private key, and then the average of update is taken, and that update is updated to the global model bit, and after that we evaluate the global model on each test data set, which again after providing goes back again to the client side and the process repeats. Where we have taken the data set as multi-cancer from cattle with 15,000 histopathogen images of 3 class. Client I have taken as 5, and per client split is train 1,400 images, validation 300, test 300, and model is pre-trained replicated model, and framework is PHA and Python. CPU is only for the running. A local report taken was 5, batch size 60, DP settings if 1, and sigma is 0.01. Coming next to the results and findings, the first graph is accuracy versus computational cost, where we can see with the increase of the computational cost, the accuracy slightly first increase and there is this fluctuation, but the accuracy highest gain is at 10, which is at the mid of the computational cost, and even after that, even increase in the computational cost does not increase the accuracy. So we get the computational cost is less and the accuracy is also high. And then the next graph is epoch versus delta norm graph. Uh, delta norm is the value where it measures how much has the model changed. At first epoch, at the starting counts, the delta norm has a high fluctuation that it drops quickly as the model is training and is learning new things. That's why it is dropping faster. But after in higher epoch, the graph is becoming stable as the learning rate is less. Then the privacy versus utility test graph, where the test accuracy is compared with the epsilon. At starting, when the epsilon or the differential privacy is very high, and the noise is very high, the test accuracy is very less. And eventually, just with a slight increase of 0.01 to 0.02, the test accuracy is increased from 40% to 70%. And then there is slight fluctuation, but the highest is 70% accurate, which is maintained at 0.02 and 0.04. Then there is another graph of epoch versus sigma, where the sigma value is adaptive. As sigma value is adaptive, the early epoch have high sigma, which is high differential privacy, and with the increase of the epoch, the differential privacy sigma. Epoch versus computational cost. As we have seen that the delta norm is reducing in a similar way, computation cost is also reducing as the time taken to evaluate the round decreases. So that in case of as the time taken computational time is reduced, as the round time is also reduced, which decreases the computational cost. Epoch versus loss, we can see that there is constant decrease of loss in training and testing, in training especially, and in accuracy also there the graph converges and achieves an accuracy of around 98%, and testing accuracy is achieved around 70%. The proposed system implemented privacy is becoming securing a secure model. trained investigative model on multi-client which datasets achieves final testing accuracy of 70%. Demonstrated scalability and robustness. Future work can be included as can be used more efficient to increase the accuracy from 70. More efficient HC schemes can be used, and hyperparameter tuning can be used, and this work can also be implemented in frequency domain processing for increasing the privacy even more. These are some of the references. Thank you.
Okay, thank you for your presentation. I have a couple of questions, but very basic. So, why does your testing accuracy, why is your testing accuracy not so good?
The main reason is as so the training is good, but the testing while testing the individual clients, the testing accuracy is getting very.
So, what is the your training data set size?
Training only we do this.
Yes, 300. And how many are used for testing?
Training is 2,400 testing is 300.
2400. And you talked about scalability. What do you mean by scalability?
Sir, we can train this model on in higher data set or scalability. It can be we can add a number of more uh, lines. Five. We have taken only 5 lines, so lines side can be increased.
Okay, but this, I think there is a scope of improvement in this particular framework. I think.
Yes,
Yeah.
yes, sir.
Okay. Again, I assume you are to be a BTech student. Oh, good. Thank you so much for my.
Yeah. Okay, sir. I have a couple of questions. So, how you have computed that computational cost here? You have compared computational cost with some accuracy, some plotting of some. How you have computed that computational cost? How it has been measured?
Time. Computational cost is compared to the round.
How you have measured that? Is it your actual time or what? That there must be some you can measure that computational cost in terms of some um, asymptotic notations like order of n, order of n. What is the computational cost here you found?
So I don't know the exact one, but the according to the time the training testing time and training time I computed.
Never compare your algorithm with computational curve means it is not your actual time, right?
Yes, sir.
Always you should present your time in algorithm time, computational time in terms of order of n, right? Order of n or n log n or n square, like that it should be. Because why it should not be in terms of your exact time? Because the machine on which you are executing your program, it may tomorrow it may show happen. Someone will take the program and it may run in another machine with high computational facilities. So at that time it may take less time.
Yes,
Right. So it is always advisable to compute the computational time in terms of order of n, which big of whether it's called as asymptotic mutations. Either big O, small omega, big theta, there are a lot of notations are there. You find in all the papers, all the researchers used to give the time in terms of that, not in terms of actual number, right? Okay. And what is the initial value of epsilon you have taken for that definition privacy? 0.
0.01.
01. How you have made it as adaptive?
It's not completely, it's adaptive and it's, as it is not fixed. It changes with the increase of local epochs. With the increase of local epochs, the epsilon decreases from 0.01 to
initial value was 0.01. Then it has got decreased. The value.
0.05.
What is the basis of that?
So, keeping it fixed, reduces stability. So, with the increase in epochs, increasing in epochs and decreasing the action privacy, where
the necessity of making it adaptive. That's what I mean. How it is. What kind of impact it will have?
so every round doesn't require so some require less epsilon. Fixing the epsilon on every round may reduce the accuracy. While we adapt the DP, where some round doesn't require that much privacy, there the sigma can be reduced.
But the graph, whatever you have shown, there is a drastic fall in accuracy with the increase in computational cost or such computational cost. What is the reason for that? What are the possible reasons?
Adapt high. Sigma. In my case, where I said adapted, I meant that.
Okay. Okay. Thank you.
Thank you for those presentations. With this, we come to the end of our technical session 4 on our IEEE CTS 2026. I sincerely say thanks to the respected sessions here for their valuable insights and their observation. I also thank all the participants for their excellent contribution and all the audience for their active participation. Thank you all. Thank you, sir.
Sir, namaste. End of session. Okay, thank you.
the academic committee and for the party and artificial intelligence and machine learning probably solutions and power system AI and speech in 2026. I am students learning even after in my village and for in village of the we will do this technical session, which covering map 4, 5, 6, 7, and 8. We are gonna use session chair and take out your names. Dr. Sunish Kumar Das, Assistant Professor in the Department of Assistant Professor from SRM University. His research area includes microwave antenna and filters, dielectric resonant antenna, 6G and 5G antenna, antenna for IoT, tightly coupled dipole array antenna. He was also appointed as research scientist at Synapse. And Dr. Lapanjay Sharma is the assistant professor from IEEE University, and his research area includes biomedical signal processing, image processing, machine learning, deep learning, optimization. We are warmly welcome them and look forward to their valuable insights. In this session, we will presentation for the following paper ID 427, 429, 437, 444, 449, and 473. So each presentation will be allotted for 10 minutes, followed by a discussion. So I kindly request all the presenters to follow the time limits. So now I will invite the member ID 427 to present their work. Kindly share your screen and begin your presentation.
Hello, good morning, ma'am. I'm from paper 427. Yes, ma'am. I will share this. Step my screen is on visible. Okay, myself Shivakala Maharaja Engineering. I am from Berhampur.
Close the book. Now continue.
Myself Dattatreya. Okay. Myself Dattatreya Sharma. I am from Weltech University, Avadi, Chennai. So, as part of this conference, we are focusing on a robust and privacy-preserving vertical federated learning framework adapted to defense against poisonous attacks. So, and from introduction, in today's world, large amount of data is distributed among different organizations like e-commerce, healthcare, banking. So here, from privacy regulations such as GDPR, they can share their general data, hard data. So for this problem, they invented a vertical federation learning to train the model, global model, and send the model updates to the central server. So here, but still the attacks are possible. Poisoning and backdoor attacks still possible when malicious client update their wrong business attacks into the vertical federation learning can maybe results in of low accuracy and privacy will be risk. So for this problem statement, even though vertical federation learning protect raw data, it still faces major challenges. Attackers can manipulate model updates through poisoning and backdoor attacks. Also, since data is encrypted and partially useful, it is adaptive defense system. So, based on the risk score, we find out the attack where it is a fair attack or it is an unfair or poisonous attack. So, these objectives enable collaboration with the sharing data and prevent poisoning and backdoor attacks and reduce privacy leakage, maintain high accuracy. In the methodologies, we use the vertical federation learning. We know about vertical federation learning. Multiple clients train their local without sharing their raw data. Only model updates which is embedded are sent to the server. To protect the system, we use the multiple defense techniques. So, such as FL Plus for privacy protection and VFlip to secure embeddings, gradient classification to reduce malicious impact. Safe speed is for anomaly detection, and finally the adaptive defense selector. This adaptive defense selector uses the risk score. Based on the risk score, if the risk score is high, then the update model update will not be accepted. The risk score is medium. This four algorithms will try to reduce that and send to the general and clean update to the central server. So if the risk score is very low, it will accept directly. Or it is an architecture diagram. And this system consists of multiple clients and central server. Each client trains their data, local data, and sends updates to the server. Some updates may be normal, while some may be malicious. If we directly aggregate updates, the model may be corrupted. So we use the defense mechanism to detect and filter the malicious updates. Finally, the server generates secure global models. So techniques we use vertical federation learning and straight learning architecture, FL plus and vertical federated linkage information protection and gradient stratification, and finally defense elements. So these are the table when we try to execute the different data sets. These are the results on attack success rate. We achieve the model accuracy of 96% and reduces the risk. So we have the graphs when compared to the without with defense and without defense. So in the result, we evaluated on model datasets like MNIST, CAFAR, and fashion MST and heart disease. So finally, we achieved the accuracy up to 95% and attack success rate is reduced to around 56%. The privacy leakage reduced by 49%. These are my recommendation. Okay. So your name is Tatkar Sharma, right? Tatkar Sharma. Very good education. So I have few questions. Yes. So just go to the first slide, the title slide. I think there is little change in the title. And I want to suggest, Madam, coordinator, can you just change the title because it was privacy research. Here it is enforcement privacy because the title has been changed. Okay, sir. We can go to that. No, Sonic. Yes, sir. 427, author, do you have this ID title? Actually, we have to separate the title for this ID in CMT. Author Dattatray. Yes, sir. We have a problem. Actually, don't have this title for CMT. Sir, I think it is same only, sir. 427, you check your paper ID. 427 paper ID, we have separate ID and separate title. Sir, same only, no, sir. We have received mail. No, you check CMT, then you again you will talk to at the end. Okay. Next paper ID, who is there? Let's see. 429. 429. Paper ID 429. Are you there? You please stop presenting. Okay, we will come to you over phone. Yeah. Next. Evaluation system.
429, are you there?
427.
437.
437.
437.
Zero. 429. 429, you were there. Why don't you respond?
Connectivities.
Then next 437.
437. 444. 444. 444, are you there? 449.
Yes, ma'am, I'm here.
You can start your presentation.
Yeah, sure.
Kindly share your screen.
Yeah, sure, ma'am. Hello. Is it visible, ma'am?
Yes, yes. Make it full screen.
Yeah, yeah.
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 Continue.
Yeah. Yeah, good afternoon, everyone. So, my name is Tanjin. So, today I'm going to present a research work titled as Enhancing the Speed and Motion Recognition Using Wave 2 on Webs 2.4. So, our paper ID is 449. So our protocol is human emotions plays a very important role in a communication. So when we speak, our voice will not carry a word, but we express a feeling such as happiness, sadness, anger, or fear. Uh, teaching emissions to understand these emotions can improve the human-computer interaction achievements like the virtual assessment and healthcare monitoring and customer support systems. So we have using as a speech emotion recognition. It is a technology that identifies the emotion from speech signals and earlier approaches mainly developed manually and extract features such as the MFCC and which and these methods requires the exact knowledge or trained performance fully when speech conditions change due to the noise or speakers variations. So to overcome these limitations, we use a transform-based deep learning model where called Wave 2 PC 2.0, and this model learns directly from a wave raw audio, and these signals without manual features extraction and captures the important information from the speech. So we have taken the dataset as a TSS dataset. So it was containing the male and female voice notes. So we have divided the dataset as we are having the five labs. So happy, sad, here, and so these are the dataset labs we are having. So we have been divided for dataset into 80 and 20, 80 for planning and 20 for testing. Mhm. And then, so, before, continue.
Are you there? 449.
Hello, ma'am.
Continue.
Can't hear me. uh, we have studied some literature survey. So we are having three different types of traditional methods we have seen. So one is a traditional method and another one is a deep learning based method and self-supervised transformer methods and research gaps. So these are the literature reviews that we have been studied. So our proposed model, after analyzing some existing methods and their limitations, we have proposed a transformer-based speech emotion recognition system. Firstly, the proposed system will take a raw speech audio input, and the proposed system and the audio data set. First, it will pre-posted to main uniform format, and the wave 2 and BC2 2.4 model will automatically extract the features and extract the features using a commercial encoder, which is named by CNN, and the transformer encoder learns the conceptual emperor information from the speech signals, and these extracted features are passed through the classification layer, and finally the system predicts the five classes, which is angry, sad, and fear, and neutral. So this is our proposed model. So we have, as I told that the proposed model we have been concluded with using the wave 2 and VC 2.0, which is we have also used it as a CNN also, and we have taken it 5 classes, and we have checked with the several models, and which is RNN and ResNet and Grid and our proposed model. We have checked with the accuracy, and we have taken from literature review and the survey. We have checked with other papers that will that accuracy for their models. And by conclusion, we have taken our proposed model, which is getting a good accuracy compared to that. So so this table will compares the performance of a different models used in a speech emotion recognition. And the traditional models like RNN achieved a lower accuracy due to limited conceptual learning, and CNN and ResNet model improves the features extraction and increases the performances. And the transformer-based models such as Wave 2 and VC2 captured a long rate speech dependencies more efficiency. So our proposed model achieved a high accuracy, which is 98.9, which is a self-supervised learning, and helps the model learns directly from the few audio signals. So, our conclusion in this work, we have developed a speech emotion recognition system using a Wave 2 and the WES 2.0 model. This system learns directly from the raw audio signals without a manual features, and the transformer architecture helps to understand the emotional patterns in a speech more efficiency, and the proposed model achieved a high accuracy and showed stable performance on TESS dataset. And overall, the result proves that the transformer-based model are effective for recognitive emotions from the speech. And the future work we are planning, like the proposed system can be tested on real-world data set containing like noise and different features to improve the uh, it improve the accuracy, and the model can extend to recognize a more emotional categories. So presently we have used it like 5 classes, right? We are planning for future work we can use some more classes, and we can also test in the end. Additionally, we can combine the speeches with other such as a text and such as text. So this was our project. Hello. Yes. Yeah, thank you, sir. Yes, sir. So can you please?
Can you hear me now?
Yes, sir. Yes, sir.
Yes. What speech?
Yes, sir.
Oh, five, six different types.
Yeah, 5 classes. Yes, sir.
Five classes. So you are planning for what? You increase with more classes, right?
Yes, sir.
And whatever it has shown in the comparison, like some possibilities of input point,
Yeah.
comparison with other models. Other models also have only these classes or they have more classes.
Yeah, they have some. They have been taken like 4 classes. Some other person has been taken like more classes from that. They have some of have been taken 6 classes.
Which one more classes here?
So
Which model have taken more classes?
yeah, more classes that have been taken as an RN. So yes, sir.
So they are actually
Yes.
so
Yeah, yes, sir.
more longer.
They, yes, sir.
So how many period comparing this how many classes they have also taken?
Yes, sir.
So that will be fair comparison.
Yes.
When you see directly that will make the model is I think what is good for now. You also include which how many classes?
Yes.
And second question is that so whatever your proposed model, is it the improved model of this to DC?
No, sir. It is existing, but they have been used some less. They have been first. They have been taken as a 2 classes, as we have been know like mostly the ML is you constantly was concentrating in images mainly. So they have been taken a inspiration like they have been used for the 2 classes, and then they have been checking like recently I have told you like they have been taken like a data set as a girl and boy. So which is the girl's voice note and the boy's voice note. So they have been not taken as emotions. So we have been taken as an emotion data set, which is like a sad, angry, fear. So we have been taking this, and then we have been tested with a V model, and then we have also come across the literature review. There we have how much accuracy they have got.
So with respect to the foundational one also, is it the
Yes.
same?
Yes, sir. Not only for using only CNN, we can't develop the accuracy. We know that only the CNN that can be used for the raw images. So the CNN can helps to get the image data set, not for the so we have been used as a web from DC. So it is better.
What is the next plan?
So we are trying to develop some more classes. So we are trying to add some more classes. So presently, we have used five classes, so we are planning to add some more classes, and then we are also trying for a real-time data set containing like noise. Like presently, we in our data set that will be containing only the voice note. So we can create some other noise in that voice note, and then let's see that whether that model can predict the correct model, like correct classes.
Thank you.
Thank you so much.
Okay. Thank you, Sonic sir. Lakan sir, do you have any questions? Did you compare it with other transformer-based models?
Yes, sir. We have compared with we have checked with the previous literature reviews, which is having a good accuracy compared to us. So we have checked with that model, sir.
So where is that comparison?
Yeah, actually, it was with my friend. I have just noted the accuracy which has been shown here.
No, this you are which transformer model you are using here?
So our proposed model has been used as Wave 2 and DC2 proposed model we have been used.
Wave
So Yeah,
vector, wave to vector.
yes, they have been used only that model, and we have been used it with Wave 2 and BC2, and that's also we also use it as a CNN also. We have used both models. As you see this that proposed model. After the feature extraction, we have used a CNN for max pooling and the soft activation.
And you should have present your architecture properly. In the
Yes,
title,
sir.
you have written wave to vector,
Yes, sir.
but you have not given its architecture, how it looks like.
Yeah. In our paper, we have mentioned that, sir.
Okay. Thank you. Okay, sir.
Okay, sir.
Okay, sir. So you can stop sharing and leave the meeting.
Yeah.
Next is
Okay, sir.
paper ID 473. Are you there? 473? No. 429. Are you there? Paper ID 429. Yeah, you can start presentation by sharing your screen.
Yes, sir.
Your screen is visible. Yeah. Yeah, your slide is visible. Make it full screen.
Yes, sir.
Your screen is not visible now.
So, one minute, sir.
You close this window. Close this.
Yes, sir.
Now you make it full screen and start with it.
Yes, sir.
Yes. Yes.
Yes. So, myself, Nandu, given more hands from Tech University from Chennai. Our project exists on team model framework for cross convergence relational integration. Nowadays, agriculture regions are to flooding and water conservation due to climate change, resulting in crop-based transition of irrigation and accommodation of for farmers. Existing hydrologic mixing systems are limited limited carbon such as rainfall or soil moisture. These models fail to adapt entirely to real-time economic conditions and system agriculture. Yeah, this is the problem statement, sir. And use the literacy survey and going to system architecture. The reason system architecture is proposed team set of framing of the pre-trained application of data aggregation, hybrid data learning, and decision support visualization. In the first layer, multi-source data is collected from IoT sensor deploying in remote sensing platforms, GIS database control, and information. On the second layer, implements a hybrid CNN LSTM model. CNN layer analyze data from satellite imagery and GIS layer to identify flood-prone patterns, like while LSTM networks process environment data such as rainfall rates and soil moisture. These facial and temporal features are fused into a vector presentation enabling to system to model real world items and using the methodology system overview. The deep hydro framework demonstrates strong predictive performance across multiple project zones, including semi-arid and coastal regions. Experimental evaluation using controlled cross validation achieves an overall accuracy of 4.2 below square 1.14% and mean accurate error 1.72%, including high reliability. Additionally, the system improved water use efficiency by 12 to 15% and increased crop yield by 9 to 14%. Excuse me. So can you please come on with camera? Yes, sir. Yes, sir. Um, yeah. And this reason that advantages of multi-modal collaboration generates research, promotes accuracy, identifying clear it predicts the friends before ahead and it will move if you give so much of enhancement. So future development will focus on the model throughout the AI devices to enable real-time prediction directly in advance. So without limits of survival. Yes, sir. You please go to slide number 8. Yes, sir. From which software you have designed this diagram? Sir? How you design, how you have to design this software, which tool you have to. It is basic concept, three architecture on the it's not yes, sir. Which tool you have used to draw this diagram? I want the name, I want. I want to let them know the name, which I want to draw the same diagram. What should I do? Okay, so from where you got this data IoT, then satellite, then GPS. Where is that? Where is those data sets? Sir, we have downloaded from Canva. Where? Show me the link. Tell me the link. I have to see. Sir, it was my friend. I saw that. He said IoT also data set, satellite data set is there, then PS is also there. And then other methodological data, which data source is provided. Which source is providing so much data? Sir, it was in the science laptop, sir. And it was in the science laptop, sir. This is not a tech school presentation, dear, that you are saying it is my platform or it should be either online or if you have done it with some collaboration or with some uh, agency. Usually emergency when run out of space.
Either you show me the link, otherwise I will declare that this work is not done. This work cannot be done.
So actually was out of space in the emergency. You have any other that maybe when any Excel file or things anything can be just as in this laptop now this
I will suggest organizers to again review this paper, sir. Yes, yes, paper ID 429 will be again reviewed. And if you suggest, we can cancel this from, we will cancel it from publication. So, if you suggest. Because your many conferences, papers are getting some issues. Yeah, yeah, yeah. Because of that, full conference papers are getting issues. So, we'll
like
review
he's
this.
not even
We got this programming one. Draw this diagram for my. Should I do? Let me suggest. That's it. Okay, sir. That we will do, sir, for 429. Thank you. Next. Shall we go to next ID? Tonic? Yes, sir. Yes.
yes sir yes sir yes yes
So next, 457, are you there?
Yes, sir, I am there.
Yeah.
Am I audible?
Yeah, yeah. You can start your presentation by sharing the file.
Yes.
yes
Good afternoon, everyone. I am Vaibhavi Patil from the Department of Electronics and Communication Engineering from KLE Technological University, Belgavi. Today, I will be presenting our research work on the study and simulation of system control systems for enhanced driving safety and comfort. This work covers developing a low-cost, intelligent cruise system that can automatically adjust vehicle speed, detect obstacles, and improve driving safety and comfort. So coming to the project, our work scenario, when driving highways, long distances, drivers continuously need to adjust their speed, traffic variation, moving vehicles. At the same time, they must maintain the proper lane division and safe distance. This continuous small adjustment increase the driving fatigue. Intervention. Design a smooth clear system that can detect of and adjust the speed automatically. Model and validate and testing the same system on the embedded hardware using Raspberry Pi.
You reduce your surrounding noise.
Okay, sir, is it audible now?
Yeah, now you can continue.
We reviewed several research papers related to the ADAS and lane detection systems. Existing works mainly focused on lane detection or obstacle detection or driver assistant features separately. However, many systems lack integration between them. Some papers only introduced lane detection, some obstacle detection. Our work integrates simulation and hardware together to create a complete SSC prototype. Coming to the components used for developing this system are Raspberry Pi, which acts as the main controller, camera, here we have used IP webcam as the input, ultrasonic sensor for obstacle detection, LM98N motor for rotating the DC motor. Then we have used the power supply. The Raspberry Pi receives sensor data and makes real-time decisions to control the motor speed. Coming to the block diagram, this block diagram illustrates the overall flow of the system. First, the sensor and camera inputs are provided to the Raspberry Pi. Then MATLAB simulation is used to design and validate the control logic. The Raspberry Pi here acts as the main control processor and checks whether the obstacle is present within a safe distance or not. After this, there are some features. This is the main three blocks. First is the lead car, next is the EV car, and middle one is the adaptive cruise control system. Lead car, which is the car moving in front. Ego car is the car controlled by us, which is installed, which is having cruise control simulation. The results got from cruise control are on this slide. The simulation result shows how the vehicle responds to different situations. When no obstacle is present, the vehicle maintains constant cruising speed. When an obstacle appears in the system, the speed gradually reduces. And if obstacle comes within the critical distance, the vehicle stops safely. Along with the cruise control, we have implemented the braking system, which mimics the anti-lock braking system in the vehicles. The braking model ensures controlled deceleration, prevention of vehicle lock, and smooth stopping. Here are the results which we have got from the braking system. The speed of the vehicle is initially speed and then it reduces gradually without locking the wheels. Now coming to the hardware implementation, this is the hardware prototype which we have developed. After the simulation validation, we have implemented the system on the hardware. The Raspberry Pi reads real-time distance data from the ultrasonic sensor and generates PWM signals to control the motor. Here the DC motor acts as a control device for the wheels. We have tested this hardware on four different test case scenarios. First case scenario is no obstacle ahead. When there is no obstacle ahead, the vehicle maintains constant speed without unnecessary braking. The second test case scenario was there is a stationary object in front of vehicle. During this time, the system gradually reduced speed and stopped safely before the collision. The third case, test case, which we have tested is lead vehicle is faster than our vehicle. The system maintained its current speed without unnecessary acceleration. And the fourth test case was lead vehicle slower. When the lead vehicle is slower, the system reduced the speed and followed the vehicle at safe distance. Across all these test cases, our speed transitions were smooth and there were no sudden jerks and safe distance was maintained. These are the results which we have got from the test cases. In conclusion, we successfully developed a cost-effective adaptive cruise control system using simulation and embedded hardware. The system can maintain safe distance, it follows the lane and adjusts speed automatically. These are the references which we have referred while doing the literature survey. Thank you. Sonic, sir, you can continue. Yes. I was like the simulation model that we can use.
If we will delete this word, then what is just simple push control?
It adjusts uh, it sets the means it runs by the speed set by the driver. But in adaptive cruise control, it detects the surrounding with obstacles. If the obstacle is there, then it will adjust the speed accordingly. If there is need of reduction, then it will reduce.
And it will increase also.
Yes, sir. If the lead vehicle is moving with a faster speed, then the ego vehicle, which is our vehicle, which is controlled, then it will be also moving with a greater speed. But it moves by following the safe distance.
In that case, have you tested?
Yes, sir.
Okay. Good one.
Thank you, sir.
Okay, thank you. Good. Next. Next, paper ID 444. Are you there?
Yes, sir.
Yeah, you can share your screen and continue your presence.
Okay, sir. Good afternoon, sir. My name is Shomojit Datta. I am the student from Narula Institute of Technology from MCA. My paper name is RGA DQN based project. Yes. Yes, sir. Yes, sir. Raghu sir,
Yes, yes. Yeah. You have also changed your title for presentation as compared to your paper.
Yes, sir.
Yes, in CMT you have title. Here you have shown the title. Who had
My title. Hello. Hello, sir.
Yes. In CMT, see in CMT your title was an adaptive GA DQN framework with Q guided crossover for client research scheduling. You have changed the title. Why you have changed the title?
Yes, sir.
Why?
Because that this is the suitable for this present.
No, you cannot do it like that. The title.
Okay, that's fine, sir.
So, Chase, what we will do? We will allow him for presentation. We will postpone his presentation. Other sessions.
We can change the title. Well,
Yeah.
already the one. Let it change the title.
Okay. So now, can you change the title as well to CMT?
Same title, yes.
Somyajit.
Yes, sir.
Yeah. Please do that.
Sir, can I present, sir? I am paper 4. Yes, sir. We test still so we use some data sets. So we need to do in future implementation. Just from 2 to 4 clients or 5 clients. Sir, we but I will show that is algorithms and that's what from us.
Okay. Thank you, Swami sir. So now 473. I am ready to present. Dattatre, you can stop sharing.
Okay.
Yeah, I'm ready. Can you guys hear me?
Yeah. We can hear you. Please share your screen and start.
Yeah.
ସଟରଡେ ଦିନ ତମେ ସବୁ କରିବ We can see your screen. You can continue with presentation.
Oh, okay. So can you guys hear me?
Yes, yes.
Okay. So my name is Satyanath Kumar Bundu. I'm from Dallas, Texas. I'm currently working in a fintech company, Populous Financial Group, as a tech lead for integration platform team. I have over like 15 years of experience in enterprise application integration, and this paper is something related to the work that I have done in all my experience and some enhancements and advancements added to the integration. So the title is like the scalable middleware for secure and fault tolerant high throughput enterprise application integration DI across the hybrid cloud environments. So building something which can manage applications or route between both on-prem cloud and also the cloud native applications. In the next slide, we'll talk about the roadmap of this presentation, where we discuss about the motivation behind and the problem statement. So the architecture that we came up with, for modeling to have be used for building is like throughput, latency, availability, and security coverage. And for the actual process itself, the economic control, we use two algorithms, one for provisioning and one for runtime adaptation. And for implementation methodology, we use hybrid test bed, as I mentioned, both on-prem and cloud instance, with relevant benchmarks to track the problems. And the final slide will show the results of it. So another motivation regarding this hybrid cloud application spans on on-prem systems and services and also SaaS or iPaaS endpoints or message brokers. And as a integration architect or engineer, we must see it is meeting all the security, fault tolerant, and high throughput simultaneously. And for traditional ESB or the enterprise service bus type architecture, the point approach that we use struggles with like the rigidity where we use static routes and adapters, and also the recovery gaps where we are limited by number of replays for any transaction or failovers in the nodes. And also it is fragmented across all over, and there is no centralized telemetry or the centralized queue system. Coming to the objective, build a scalable middleware layer to provide a unified routing, security, and resilience layer, and it can deliver a robust throughput and less latency, where we maintain a very high availability under the realistic volumes. So again, coming to the architecture, we have a policy router which routes all the traffic and also as a distributed broker, which helps in routing different event messages across the platforms. At the same time, we will have the security enhanced and also have observability plane, which is centralized to observe all the metrics. And the model actually was built considering the capacity, throughput, latency, and availability, like I mentioned, and the autonomy control. It's done using two algorithms. One which is provisioning, and the second part where we do the dynamic rerouting or the scaling. And for evaluation, we used Death Star bench and trying to get on hybrid Kubernetes with injected forms. Um, and as you can see, the results, we observed a 61% increase in throughput and decrease in latency by 37%, and availability also increased to 99.96%. And here are some of the parameters that we consider while building this model, where the message rate, lambda, should be always less than the actual capacity rate of that node. And the second one, throughput, where it is like the sum of message rates across different active flows. And latency, where it considers processing delay and also propagation delay across different nodes. And so checks for the availability using the individual node availability across the clusters. And it also considers the security. What are the events that we are getting are secured. These are like the main parameters considered building the model. So here you can see the different considerations in both the algorithms that we're using in the model. So in the algorithm one, it enumerates the paths respecting the security policies, and then it selects the feasible path for all the different routes that it has to take, and where it identifies the integration flows and endpoints that we use to construct a hybrid topology graph, and we estimate the message rate or the events rate that we get, and it makes sure that it's always less than the threshold capacity, and it evaluates the latency by considering both the processing and the propagation delay, um, and configures replication and failover groups, and change or any like events going beyond the thresholds that we specified. It will do the dynamic rerouting and scaling based on the second algorithm. And those metrics are like fed to the first algorithm again, which it uses to uh, make any changes to the ini. In this, where we used a private Kubernetes cluster hosted on-prem for some integration points and also for collecting some of the benchmarks. We also use a public Kubernetes cluster for hosting additional microservices, and SML broker part we built, which routes services across both cluster as a single path.
You have 5 more minutes to finish the presentation.
Yeah, it's almost done. So the baseline, here you can see the differences between the baseline and the SML. The platform native queues with direct to point-to-point based one. And here you can see an SML approach is like unified with replication failover and back pressure control, which monitors all the throughput and all. With the policy router with the security enforcement and then the integrated observability plane instead of a fragmented one, where we can get all the centralized measures. So these are the different metrics that we collected during the testing. The throughput of the events that we got, the latency observed, and also the availability of the overall cluster and the message loss rate there are. And here, if you can see differences between the baseline and with the SML approach, uh, with the increase in number of clients reaching those services, you can see there is a consistent increase in the throughput. And overall, we observed a 61% increase in the total throughput compared to the legacy model. And here you can see the latency and availability also has increased. Latency decreased from like 182 to 133, and availability increased from 98.1 to 98.96. And we observed no loss in events, even during the broker failure or any node outages or node listing. So, in conclusion, it was a vendor neutral, policy-driven cloud integration, which increases the throughput by 61%, latency has decreased by 13%, and and during the testing, we haven't seen any losses updated. And you can see there are different references that we referred at the end of this presentation. Yeah, that's all I have.
Sorry, if you have any question, then ask. Rahul sir? Hello, sir. Yeah.
Sorry, repeat that question again. Which software or tool you have used for implementation? So this is done with Kubernetes for managing the cloud and on-prem instance. And the code is like done using microservices that are available. And why you selected means this middleware security. I've been working on it for the last 15 years. Enterprise application integration. Developer initially, and was currently as a technical lead for that in one of the fintech companies. So I did it based on whatever flaws that we observe in the present system that we use. This is the same issues. It was all like simulated, but on an actual Kubernetes. But whatever the application that we use for collecting all the metrics, those are not like real time applications, but open source it will still like similar to an actual application. Okay, thank you, sir. Right. Thank you. If there is no question from my side. Good.
Are you ready?
Yes, sir.
Share your screen and begin your presentation.
Still stamped so thanks.
Yes, sir.
Yes, please.
Good afternoon, sir. My name is Shomoji Datta. I am from National Institute of Technology in HCS student. My project name is
You close the front window. Yeah. Then you, yeah, you can, yes.
My project name is an adaptive GA DQL framework with queue-guided crossover for cloud resource scheduling. Cloud task scheduling. Cloud task scheduling means here there have made different types of tasks. We distribute the task efficiently from efficiently different types of results, different types of workload. This is called cloud task scheduling, and we propose a GA and DQM algorithm. GA means genetic algorithm, where we here we have different types of solutions in global search. That this algorithm is a which solution is best for the task scheduling objectives. Objectives of this project is to design a hybrid approach, which is called GA and TQM approach, to reduce mixspan and efficiency and enhance a queue-guided mix crossover. It is very useful for manage workload across virtual machines. This model proposed on AWS EC2 using a real cloud setup. RGA, our approach, RGA is global search and generates different types of solution. And the DQL is decision making, which is suitable for this task scheduling. And Q value, Q crossover takes intelligence and combine these two algorithms to optimize the output and the utilization and reduce the mix value. One control in cloud system architecture on AWS execute, here we have one controller and 8 workers. In this model, I propose
we propose the hybrid GA plus DQL. GA where different types of task is input and then GA globally search with different types of solution. Then DQL, evaluates which solution is best. Then the Q-guided crossover, which is combines the high quality of resources. Then we optimize the PM and reduce the span and balance with PM utilizations. And then we distributed the workload. Firstly, the task will come in the PM. Then it's initialized. GA could GA could initialize different types of path or solution, and DQN gets best fitness and then it goes to Q guided, which is GA and DQN intelligently crossover and mutation. Then it gets us a best path I which we which is how the workload distributed. There have input and output. Input parameters are we take number of tasks, means how many tasks are come. Number of PMs, how many PMs are available. Task workload size, GPM setting, and DQN setting. And the outputs parameters are make span, experience, what is the execution time, which is the best scheduling solution, and efficiency gain, PM execution time, and Q value trend. Mathematical. In this section, we learn how the GA and DQL combine each other and gives us the best path and reduce the mix span. Accuracy comparison of scheduling approach. We have whose two algorithm, GA algorithm. GA algorithm have different types of globally solution, but it cannot give accurate path. But the DQM have intelligence to get the accurate path. And I take these two algorithms and combine them, and then I approach the hybrid GA plus DQM, which is intelligent and reusable. Here we saw two pictures. First picture is worker progression in different types of waves, and second is worker task distribution visualized. In this first pie chart, we see that different types of algorithm and different types of efficiency. Our focus model efficiency is based.
second is the task load. In the second, I compare the mid-band reduction with our proposed model with the another algorithm. In the second, our I2GA proposed model mid-band is 44.45%, which is highest mid-band reduction. Future work. In future work, I incorporate the dynamic workload and real-time transit with reusable adaptability and optimization and cost of optimization technique and energy efficiency, exploring transfer learning technique and adapt model to diverse platforms with minimal retraining. Thank you, sir.
If you will see, you can answer.
Yes, yes. I have one question. What is slide number 11?
Okay, sir.
Go to 12, sorry, go to 12. What is next one?
Next one means real-time optimization. Means time, how I optimize the time.
But you are showing that significant reduction in next one means significant reduction in optimization. What?
Sir, significant reduction in means. Sorry, I cannot understand. Sir, feel. Sir, question repeat, please. Hello, sir.
Yes, my question is what exactly is the next question?
The next one means, sir, efficiency timer means how much I optimize that task load I distributed from from different types of virtual machine.
So you have written that significant reduction in next one. What does it mean?
Sir,
What you have written?
it means that same things.
It means the same thing. Okay. So how? What was the technique? I mean, what is the technique? What is the approach? How we are able to reduce that?
Then firstly in PM, we take we load the task. Then the GA algorithm is approach different types of globally path, and then the PQL approach that which algorithm is which path or which solution is best for the efficiently I distributed the task and
So
the
that is, but I understand. You are repeating the same thing, but somehow we are missing that point. No problem. Okay, no problem. Fine.
thank you.
Thank you. With this, we come to the end of the technical section 7 on our AIML CTS 2026. I sincerely thank for the respected session chair for the genuine insights and observation. I also thank all the participants for their excellent research knowledge. Thank you all.
Thank you.
Okay.
Thank you, sir.
Thank you, Raghu sir. Thank you, the organizers, for inviting. Nice sessions. Thank you.
Kindly fill the evaluations and send to
Yes, madam. I'll fill it and I'll send it.
Okay, sure. Thank you so much, sir.
Thanks.
Problem. I mean, your system, how to interact with the system.
साउंड बंद कर दिया साउंड बंद कर दिया
You should be follow like so it is not like compared to the system. Compared to the system, it's new.
And it's a little frequency. But as you know, the power is a power system. Not a power system, but frequency doesn't have frequency. If the initial frequency is so decrease by the help of APR, automatic voltage regulator, or and by the help of APR, rating power compensating the rating power. The frequency is above 50 and by the help of APR also, then we can increase the frequency. That is 50 watts.
You can use statement active power depend on what the I can also use slide number 10 of this that is I think states, right? States, okay, the higher axis. And also controller, the controller creating controller uses the whole, not the exact way of showing in pop diagram. That is not the correct way to get the input. It's not like okay, on your system architecture, so the system architecture, and this kind of whatever you have written in it wrong. It is not like TLB off. So whatever you have shown here, it is the controller parameter. To show the system architecture, for which system you have done this work. Also,
So this technique is already outdated one. So many recent techniques are there. So using that you should have read on your work quite clearly. So some advantages should be there over other so that you are selecting this technique. What is that advantage so that you have chosen clearly tell me. And also your documentation use clearly. You have not shown the system architecture, then so you are showing only the TLP output. What does that mean? It is not TLP output. What the proposed system, whatever work you have done, so it should be any frequency deviation, time and power, you have to improve for that, any more work. And for mathematics 295 for grade. Especially visible. If they can get the potential they operate, then we thanks to the organizing committee of Aimlcps Conference for accepting my paper to present in this. I am seeing my cycle from positive and information technology to application team have been progress. We are ready to identify time. Artificial intelligence AI optimized coordinated control of alpha capacitors and frequency for frequency stable enhancement in renewable and executive magnetic process. So coming to the main highlights of this work. Please present your opinion. Optimization techniques applicable to the performance index of integrals wherever ISC. And the efficacy of PIDF is showcased with PI and PID control performances. And further, the impact of communication type layers on system performance is also demonstrated. Later, the coordinated control strategy of alpha capacitors and frequency is tested, and the performance enhances at the end of the system performance. Finally, sensitivity analysis is conducted and validated the proposal control scheme. This is the concept test system which have been concept of the investigation, which is consisting of two control regions, and each control region consisting of the generation units like thermal, hydro, and wind. So you can see on the extreme left that is equal of minus s tau d, which is the communication time delays. And to perform the research work more close to the realistic practice, the non-linearity constraints like generation rate constant GRC and GDB is considered for the thermal and hydroelectric power stations. So this is the system. And communication timeless, the internet power system network is of very wide extent, and which consists of different units to transmit and receive the data from various locations. And definitely to transmit and receive the data from remote terminal units, the communication peripherals are preferred. And these communication peripherals can perform that new research work have been considered. So that's why this motivates me to consider this communication time delays and to demonstrate its impact on the power system stability. So it is modeled as equal of minus as tau d, where tau d is the time delay parameter and it is expanded as a Taylor series form as 1 minus tau d by 2 by s by 1 plus tau d by 2 s. The time delay parameter which we consider in this work is 0.25 seconds. And this is the structure of TIDF controller which I have taken in this work. So consisting of KD, Ki and KD as its gains, and N is a filter and a small n which is a part of tilt parameter. And the parameters of these parameters are intended to optimize using the Fructware algorithm based on ISC performance data, that is integral square error. The integral square error function is formulated by considering the constants delta f1, that is deviation in area of frequency, delta f2 area to frequency deviation, delta p1, that is time buffer deviations. And later, we adopted the coordinated control approach of ultracapacitors and frequency. So why we consider the ultracapacitors is they can inject or absorb the active power in a short period of time because they are having high power density. So with this nature, they can able to suppress the frequency oscillations in the integrated power system because so with this capability, they can able to mitigate the real power mismatch, which is the major culprit for the deviations in system frequency. And this is the structure of triple C, which is elected as a damping controller. The triple C is connected with the tie to suppress the tie buffer deviations in further. So coming to the simulation results, this is of case 1, analysis of multi-realistic integrated power system under Fructware algorithm due to controllers. So to get the most comparative approach, the different controllers like PI, PID and TIDF are elected as secondary regulators, one after the other, each independently. And all these controllers have been optimized using the Fructware algorithm. You see here the results. Results which are in red color, that is of TIDF controller. You can see the responses delta F and delta P1 to delta F2, they have been retrieved with less peak undershoots, less peak overshoots. The oscillations are also much mitigated and attain the steady state time. You can conclude that TIDF is performed much better compared to that of classical PI and PID controllers. So coming to this second case, in this we demonstrated the impact of communication time delays on system performance. Here the system is operated under the TIDF controller, optimized using Fructware algorithm. At one instant we consider the communication time delays. Another instant, we ignore the communication time delays to showcase its impact. You see, with communication time delays, definitely the deviation in system performance is more. Why? Because with communication time delays, definitely the action control signal that is delivered from the command center should be delivered to the controller which is situated in the plant location. They should be done with a certain time delay. With this time delay, definitely the mismatch in real power will be extended to a certain level. So with this real power mismatch, there will be more deviations in system performance. So in realistic practice, every interconnected power system is incorporated with communication communication peripherals, and these communication peripherals have the inherent nature of communication pipelines. So these communication pipelines are having a significant impact on system performance, where most of the researchers are omitted or are not considered for the investigation purpose. So in such a case, if we design a controller without taking any communication pipelines, that might not yield a better stability results. That might lead to system inevitable performance. So later we incorporated the ultra capacitors and with the to further compress the external deviations that emerging in communication bandwidths, we adopted this territorial control strategy. So with ultra capacitors, there will be a considerable enhancement in system performance, both in terms of peak undershoot and thus the time taken by the response to maintain the stabilization. And with ultra capacitors and triple C, a little bit more enhancement in the system performance is achieved here, along with the TADF optimizing through Parala. And these are the numerical results. So table 1 shows the responses taking time in seconds. Definitely with TADF, the time taken for the response to reach the stabilization is less. And with ultra capacitors and ultra capacitors, aided replace is even more enhanced. Table 2 shows the gains of various controllers which are implemented in this work. All these parameters are retrieved using the output algorithm. The bar chart clearly shows the comparative responses every 9 seconds. And this is the sensitivity test. At the secondary level, we proposed the profile algorithm based TADF controller, and the territorial level, we proposed the ultra capacitors and triple C. So to assess the marginality of the proposed control technique, we conducted the sensitivity test in terms of plus or minus 25% of nominal loading. And the nominal loading we have this network way. And in that, even though percent is not, so then for changing load also, the design controller at both secondary and territorial level is need not be optimized again. So what we optimized earlier will deliver the better results. Even the load is changed from plus or minus 20%, 25% of loading. So from this we can conclude that the proposed control strategy is robust. Coming to the conclusion, the analysis study is proposed on two areas of power system, and to get the realistic analysis, all the non-linearity constraints of GRC dedicated communication time delays are considered, and the effect of communication time delays on system performance is revealed. TADF based protocol algorithm is designed as secondary regulator whose efficacy showcased with other algorithms in the literature. To get the further enhancement, ultra capacitors and triple C aided technical strategies implemented and